Hello everyone, today we are going to build and test a 3-input CMOS NAND gate. We saw the circuit diagram in the class and analyzed it, and now we want to build it in the lab and test it. So for this purpose we are going to use a CMOS IC which is CD4007 that we have in the lab. It has 3 NMOS transistors, these and Q2 and Q3, and 3 PMOS transistors, these 3 inside my IC, and this is the internal connections for this chip. So to build this NAND gate, I'm going to make the rest of the connections and connect pin 11, 2 and 14 to VDD to power up my chip, and pin 7 goes to ground. So the 3 sources V1, V2 and V3 are going to come from 2 of them are going to come from the DC power supply. I'm going to set their value to either 0 or VDD, and the same goes for V2, and V3 is going to come from a function generator, and I'm going to set it to generate a square wave with peak-to-peak amplitude of VDD or 5 volts for this circuit, and set the offset to 2.5 volts to generate a square wave from between 0 to 5 volts. So the input signals that I'm going to test today are when V1 and V2 are set to high and V3 changes from 0 to VDD. When all of them are at high, the output is going to be at low because this is a NAND gate. So when either one of them is at 0, the output is going to be at high. So when I set V1 and V2 to VDD and V3 changing from 0 to VDD, Vout is going to also be a square wave. When all of them are at a high, the output, the amplitude of the square wave is going to be 0. When V3 changes to 0, the output is going to be at VDD. If I change any of these V1 or V2 signals to 0, the output is always going to be VDD no matter what the value of V3 is, because this is a NAND gate. If one of the inputs change to 0, the output is going to be set to VDD. So this is the circuit that I built, and this is my IC. The connections are made. V1 is connected to here, this is my V2, and this is V3 that comes from function generator that is set to generate a square wave with the amplitude of 0 to 5 volts. V1 and V2 are right now connected to 5 volts DC power supply, and I'm taking the output from pin 12 that I'm going to show in channel 1 of my oscilloscope, and this is V3 that is connected to channel 2 of my oscilloscope. So looking at the oscilloscope screen, I see that V1 and V2 are at high and V3 changes from 0 to high. When V3 is at high, Vout is going to be low. When V3 is going to low, output is going to be high. So this is the case when all of the inputs are at high, the output is going to be low. If any of one of them goes to low, which is V3 in this case, the output is going to high. So I can change one of the input signals, for example V1, change it to 0 and see how the output is going to change. So I'm going to change V1 to 0, and this is the output. Output now is at 5 volts regardless of the value of V3. I can change V2 also to 0 volts. And the output is going to be at 5 volts again. So if either one of the input signals is at 0, the output is going to be high. And that's how a NAND gate works.